Assalamualaikum and hello everyone. We are from group 11. Today we will present our assignment group discussion for introduction to mathematical economics subject with the given question. First of all, introduce to our group member. Phoenix Parent, anak lelaki Chandra Shakar 302178, Muhammad Alif Ashraf bin Muhammad Shafi'i 301388, Chong Xuan Min 300120, and lastly Nur Atika Shakira binti Kasim 301318. Question A. For a monopolist, the average cost SC of producing unit of the product is 3 ringgit Malaysia, and the demand equation is P equals to 10 over square root x. Find the total profit function. P equals to 10 over square root x. This equation represents the price P as a function of the variable x. It states that the price is equal to 10 divided by the square root of x. SC equals TC over X. Here, SC represents average cost and TC is the total cost. The average cost is defined as the total cost divided by the quantity produced. 3 equals TC over X. This equation implies that when the quantity produced is X, the total cost is 3X. In other words, the total cost is directly proportional to the quantity produced. TC equals TX, 3X. This equation is a result of the previous one. It states that the total cost TC is equal to 3 times the quantity produced. Profit equals TR minus TC. Profit is calculated as the difference between total revenue TR and total cost TC. TR equals 10x over square root x is given by the expression 10x divided by the square root of x. For profit, we get 10x square root x minus 3x. We substitute the expression for TR and TC into the profit equation. We will get the final expression for profit in terms of the variable x. It simplifies to 10 square root x minus 3x.
Question 1 to Romans. What price will give the greatest profit? First, we rewrite the square root in the function using exponent notation, which gives us 10 square root x minus 3x equal 10x. We change square root of x to power of 1 over 2 minus 3x equal 5x 1 over 2 minus 3. 5x we got from 10x times 1 over 2 equal 5 over square root x minus 3. We change 1 over 2 into square root of x and denoted as dp over dx equals 0. And then 0 equal 5 over square root x minus 3. We change 3 equal 5 over square root of x. Square root of x we change into the left equal 5 over 3. And we simplify x equal 5 over 3 power of 2 equal 25 over 9. And we got the profit 10 over 25 over 9. We got the profit RM 3 ringgit 60 sen Malaysia. Thank you.
To prove that x equals to 25 over 9 is the maximum units to produce in order to get profit, we need to do second order condition. So we need to do differentiation for first derivative of profit function, which is 5 over square root x minus 3. At the end, we will get negative 5 over 2x to power negative 3 over 2, which is the second derivative of profit function. Then we need to substitute x equals to 25 over 9 into this function. We will get a negative answer, which is negative 27 over 550, where this answer is less than 0. This was proven as 25 over 9 is the maximum unit to produce.
For question B, the manufacturing cost of an item consists of Rm 6000 as overhead, material cost Rm 5 per unit, and labor cost Rm x squared plus 60 for x unit produced. For Roman 1, the question requires us to find the total cost function. From the lesson we learned, to find the total cost function, we need to find first the variable cost and the fixed cost. We can refer back to the questions. We can see that 6,000 ringgit Malaysia as overheads is the fixed cost of the total cost functions, and the material cost are for 5 ringgit Malaysia per unit. We can state that as 5x as a variable cost, and the labor cost there's listed that x squared plus 60 ringgit Malaysia for x unit produced. So the final answer will be Cx equals to x squared plus 60 plus 5x plus 6,000 for the total cost function.
Question B, Roman 2. Find how many units must be produced so that the average cost is minimum. SC equals to 6,000 over x plus 5 plus x over 60. This equation represents the average cost as a function of the variable x. It expressed as the sum of two terms, 6,000 over x, 5 and x over 60. Taking the derivative of the average cost, 2x denoted as dy dx involves applying differentiation rules to each term in the equation. The derivative is calculated as 6,000 over x squared for the first term, 0 for the constant term 5, and 1 over 60 for the third term x over 60. Simplifying the derivative expression, we will obtain the first derivative of the average cost, which is negative 6,000 over x squared plus 1 over 60. To find critical points, we set the first derivative equal to 0 and solve for x. Rearrange the equation, we will get 1 over 60 equals 6,000 over x squared. Solving for x squared, we will find x squared equals to 6,000 over 1 over 60. Simplifying the further x squared equals 6,000 times 60. Taking the square root of both sides, we will get x equals to plus minus square root 360,000. Therefore, x equals to plus minus 600. The critical points is x equals to 600 units, because the negative root is the secret since quantity produced cannot be negative.
Question 1, B3 Romans. Within the interval 0 plus infinity, find the interval where the average cost function is increasing or decreasing. Average cost function equal to 6,000 over x plus 5 plus x over 60. To understand how the average cost function behaves within the interval, we will examine its derivative. dy over dx equals 6,000 over x power of 2 plus 1 over 60. For turning point, dy over dx equals 0. And we substitute the average cost function 0 equals 6000 over x power of 2 plus 1 over 60. And then 6000 over x power of 2 equal 1 over 60. And then we simplify, we got x equals 600. How we got 600? 6,000 times 60, and then we change from power of 2, we change to square root of 360,000. We got 600. And then in the table, x and derivative dy over dx. X is 0 less than x less than 600, and dy over dx is negative. X is 600, dy over dx is 0. X more than 600, dy over dx is positive. Therefore, increasing for x more than 600, decreasing for 0 less than x less than 600. Thank you.
To determine rate of increase in total cost function, which is 6000 plus 5x plus x square over 60, we need to differentiate the function. After we differentiate, we will get 5 plus x over 30. Therefore, the rate of increase in total cost function is equals to 5 plus x over 30.
Roman 5 question requires us to refer to the answer from Roman 4 and explain our answer. For Roman 5, we found that the rate of increase in total cost is constant and equal to 1 over 30. This means that for each additional unit produced, the total cost increased by 1 per 30 units.